Hello, dear students. You must have seen questions in your exams and other tests regarding calculation of the percentage of a particular element in a molecule. This is what we call percentage composition of a molecule. And this is our topic for today's discussion. So today we will learn how to calculate the percentage composition of a molecule or the percent amount of an element in a molecule. So, what percentage composition actually means is that when you express the relative amounts of any element present in a molecule as percentage, this is known as percentage composition. And this is done by calculating the molar mass of the compound first, and then later on calculating the mass of each element present in the molecule. So the first thing that you need to calculate the percentage composition of a molecule is to calculate the molar mass of the compound. Once you have the molar mass of the compound, then of course you can calculate the percentage of each element in the molecule. And for this you can use a pretty simple equation, that is the percentage of element is equal to the mass of the element in 1 mole of a compound, because you already know that the molar mass of any compound is equal to 1 mole of that compound. So percentage of an element is the mass of the element in 1 mole of compound divided by the molar mass of the compound, and because it's a percentage calculation, so you multiply it with 100. We'll try to learn this with the help of some examples. So the first example is that of carbon dioxide. So first we have to calculate the molar mass of carbon dioxide. Carbon is equal to 12 and we have two oxygens. So 16 multiplied by 2, that is equal to 32, plus 12 is equal to 44. The molar mass of carbon dioxide is 44 AMU, and 44 grams of carbon dioxide is equal to 1 mole of carbon dioxide. That is what you already know. Now we have to calculate the percentage of both carbon and oxygen in carbon dioxide. So the percentage of carbon is equal to the mass of carbon in 1 mole of compound. So if we have 44 grams of carbon dioxide, that is 1 mole of carbon dioxide, it will have 12 grams of carbon. The total mass or the molar mass is 44 multiplied by 100. This is equal to 27.27%. Now if you calculate the percentage of oxygen, you know that 44 grams of carbon dioxide will have 32 grams of oxygen. The molar mass is 44 multiplied by 100. This is equal to 72.72%. So carbon dioxide, or a molecule of carbon dioxide, has 27.27% of carbon by mass and 72.72% oxygen by mass. If you add both the quantities, that is 27.27 plus 72.72, this is equal to 99.9. So that is almost 100% of carbon dioxide. Let's see another example. Say we have water, and water has two hydrogens and one oxygen in the molecule. First you have to calculate the molar mass of water. So it has two hydrogens, that is 1 multiplied by 2 plus 1 oxygen, that is equal to 16. So the molar mass is 18. So 18 grams of water is equal to 1 mole of water. And now if you want to calculate the percentage of hydrogen in water, so in 18 grams of water, we will have 2 grams of hydrogen divided by the molar mass, that is 18 multiplied by 100. This is equal to 11.11%. And if you want to calculate the percentage of oxygen in water, this is equal to, now because in 18 grams we have 16 grams of oxygen, so 16 divided by 18 multiplied by 100 will be equal to 88.88. And again, if you add both these quantities, that is 88.88 and 11.11, this is equal to 99.99%. If we have acetic acid, now acetic acid has three different types of elements, that is carbon, hydrogen, and oxygen. First, you have to calculate the molar mass of acetic acid. So molar mass is equal to, how many carbons are there? There are two carbons, so 12 into 2 plus there are two oxygens, so 16 into 2 plus there are four hydrogens, so 1 into 4. And if you add all of them, 12 into 2 is equal to 24, 16 into 2 is equal to 32, and plus 4, this makes it 60. 60 grams of acetic acid is equal to 1 mole. Now 60 grams of acetic acid will have how much percentage of carbon? So let's calculate the percentage of carbon first. 60 grams of acetic acid has 24 grams of carbon because there are two carbon atoms. One atom is equal to 12 grams. So 24 grams of carbon divided by 60 multiplied by 100. This is equal to 40%. The percentage of oxygen would be, now 60 grams of acetic acid has 32 grams of oxygen. So 32 divided by 60 multiplied by 100 is equal to 53.33%. For hydrogen, in 60 grams of acetic acid, we have 4 grams of hydrogen. So 4 divided by 60 multiplied by 100 is equal to 6.66%. Now let's add all the three quantities and let's see if it is equal to 100 or 99.9%. So we have 6.66, we have 53.33, and then we have 40.00. This is equal to 9, this is equal to 9, this is equal to 9, and this is equal to 9. So almost 100%. So all of these three elements make up 100% of an acetic acid molecule. Let's calculate the percentage of each element in glucose, that is C6H12O6. So the molar mass of glucose would be, we have 6 carbons, 12 hydrogens, and 6 oxygens. So 12 into 6 plus 1 into 12 plus 16 into 6. And this is equal to 180. So 180 grams of glucose is equal to 1 mole, and 180 grams of glucose will have 72 grams of carbon, 12 grams of hydrogen, and 96 grams of oxygen. But what will be the percentage of each of the element? So the percentage of carbon in one molecule of glucose would be 72 is the total mass of carbon present in 180 grams of glucose. Multiplying this with 100, we will get 40%. Percentage of hydrogen is equal to, so we have 12 grams in 180 grams of glucose. Multiplying this with 100, we will get 6.66% of hydrogen. And what about oxygen? So the percentage of oxygen is equal to the mass of oxygen in one molecule, that is 96 in 180 multiplied by 100. This is equal to 53.33%. Now let's add all of these quantities again. So we have 53.33 plus 40.00 and 6.66. So this is equal to 9, this is equal to 9, 9, and 9. So carbon, hydrogen, and oxygen, they all make up 100% of a glucose molecule. So you can solve several other examples using this equation to calculate the percentage composition of a molecule, or to calculate the percent amount of an element present in a molecule. Thank you so much for today. See you next time with another lecture in stoichiometry. See you later.